let's take a quick look at the trig function, the sine of x, and where its tangent lines are. So if I look right here, my tangent line is 0, and that happens at pi over 2. Another tangent line where the tangent line is 0 is here, and that happens at 3 pi over 2. And we'll do the other ones. I have another tangent line here, which happens at negative pi over 2. So those are all 3 points that would be on the derivative of the sine function. What else do we know? And I know this true is because the definition of a derivative is the slope of the tangent line. Now, the other thing that we know, going from here to all the way down, I am decreasing. And by decreasing, I mean the trig function f of x is of sine x in that interval is always decreasing. The slope of the tangent line then would have to be in between and be negative in this range. And the last piece of information that I know is if I go through and draw in the slope of the tangent line. Now, if I look at the other part of this function of the sine of x, as I'm going from negative pi over 2 all the way up to pi over 2, that part is always increasing. So in this particular range, it would always have to be a positive value. So if you're starting to see this, fantastic, because let's fill in all of the missing pieces. The function is going to be increasing and then decreasing, and this is the first derivative of the sine of x, and that function is the cosine of x. So these are the two that you need to memorize. The derivative of the sine of x is the cosine of x, and if you have the cosine of x, the derivative of the cosine of x is minus the sine of x. I have a Desmos activity for us to do to explore this a little bit more. But the next one we're going to talk about is the tangent of x. Now, for the tangent of x, we actually have to go back and use the fact that I know that the tangent of x is equal to the sine of x over the cosine of x, and apply. So let's just go back over the quotient rule a little bit. It is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. So in this case, remember, u is the sine of x. The derivative of u is the cosine of x. That's the numerator. The other notation that we use is v. And v is cosine of x, the denominator. The derivative of the cosine is minus the sine of x. So to put this in our function, the derivative of the tangent then has to be the derivative of the numerator times the denominator, which in this case is cosine squared of x. I subtract the numerator times the derivative of the denominator, which is going to be minus the sine squared of x. And all of this is over the denominator, which is a cosine squared. of x. Now in the numerator, that leaves us with the cosine squared of x plus the sine squared of x, all divided by the cosine squared of x. Now hopefully you remember your Pythagorean identities. Then in this case, I remember that the cosine squared of x plus the sine squared of x is equal to 1. So all of this gets replaced with 1. So the derivative of the tangent is 1 over the cosine squared of x, which is also known as the secant squared of x. So we're going to do the same thing to find the derivative of the cotangent. So the cotangent can be rewritten as the cosine of x over the sine of x. So using the quotient rule, I can go ahead and set this up as the cosine of x is u. The derivative of the cosine is x is minus the sine of x. The denominator in this case is the sine of x. The derivative of the denominator is the cosine of x. So the dx of the cotangent of x is equal to, again, I want to take the derivative of the numerator times the denominator. In this case, it's going to give me minus sine squared of x. Then I take the derivative of the denominator times the numerator for minus the cosine squared of x all over the denominator squared, sine squared of x. Now you'll notice this with this one, since both the numerators are negative, I factor that out to give me sine squared of x plus cosine squared of x all over sine squared of x. And again, my Pythagorean identity comes to play. All of this is equal to 1. So the derivative of the cotangent is equal to negative 1 over the sine squared of x, which is equal to the cosecant squared of x.